Chapter 8 Chemical Equilibrium, Second Hour, Part 2, 8.2 Equilibrium Constant, Kc and Kp. At the end of the lesson, students should be able to calculate Kc, Kp, or quantities of species present at equilibrium. There are two types of calculation involving equilibrium constant. We only focus on calculation of type 1 in this video. And the calculation of type 2 will be covered in the next video. So please watch the next video after you watch this video. For type 1, the concentration or partial pressure of all the reactants and products at equilibrium are given in the question. You only need to insert the values of concentration or partial pressure into the Kc or Kp expression to solve the questions. Remember, in your syllabus, unit for Kc and Kp are not in SES. So the final answer of Kc or Kp is only value without unit. Let's see the example 1. The following equilibrium process has been studied at 230 degrees Celsius. 1 mole of nitrate ion react with 1 mole of hydrogen ion to produce 1 mole of nitrous acid. In one experiment, the concentrations of the reacting species at equilibrium are found to be: concentration of nitrate ion is 0.0542 molar, concentration of hydrogen ion is 0.127 molar, and concentration of nitrous acid is 15.5 molar. Calculate the equilibrium constant Kc of the reaction at this temperature. To solve this question, first, we need to write the Kc expression. Remember, the Kc expression is molar concentration of product raised to the power of its stoichiometric coefficient divided by molar concentration of reactant raised to the power of its stoichiometric coefficient. In this example, the product is nitrous acid. The reactants are nitrate ion and hydrogen ion. Then we insert the values of concentration of all the species involved where all the values are given in the questions. Then press your calculator to get the value of Kc. And remember, the unit is not in SES. Next, the second example. At a certain temperature, Kc equal to 1.8 to the power of 4 for the reaction of 1 mole of bicarbonate ion react with 1 mole of hydrogen ion to produce 1 mole of carbonic acid. If the equilibrium concentrations of bicarbonate ion and carbonic acid are 0.015 molar and 2.00 molar respectively, what is the equilibrium concentration of hydrogen ion? This example is different from the first example where the Kc value is given in the question, but you need to determine the equilibrium concentration of one of the species involved in the reaction. To solve this question, first we need to write the Kc expression. Then we insert the values of concentration of bicarbonate ion, concentration of carbonic acid, and Kc. Then solve the calculation to get the concentration of hydrogen ion. So the final answer is 0.0074 molar. Next, example 3. The equilibrium constant Kp for the reaction of 2 mole of nitrogen dioxide decomposed to form 2 mole of nitrogen monoxide and 1 mole of oxygen is 158 at 1000 Kelvin. What is the equilibrium pressure of oxygen if the partial pressure of nitrogen dioxide is 0.400 atm and partial pressure of nitrogen monoxide is 0.270 atm. To solve this question, first we need to write the Kp expression. Then we can rearrange the expression so that partial pressure of oxygen on the left-hand side. Next, insert the values of partial pressure and Kp into the expression. Finally, press your calculator to get the value of partial pressure of oxygen. So the final answer is 346.8 atm. Please take note that the values of Kc and Kp depend on how the equilibrium equation is written and balanced. For example, 1 mole of dinitrogen tetroxide decomposed to form 2 mole of nitrogen dioxide. The Kp expression is partial pressure of NO2 to the power of 2 divided by partial pressure of N2O4. At 25 degrees Celsius, the Kp value is 4.63 to the power of -3. When the chemical reaction is reversed, the new Kp prime, is the inverse of original Kp, which is 1 over Kp original. At 25 degrees Celsius, the Kp prime value is 216. Thank you for watching this video.